I'm Nick Jennings and I'm a Professor of Artificial Intelligence here at Imperial College London. I'm also the Vice Provost for Research and Enterprise. I got interested in AI actually as an undergraduate. I did computer science as an undergraduate, and we got exposed to some introductory basic courses on AI, and I thought, well, this is by far the most interesting area of computer science, and I wanted to find out more, and then I went to do a PhD, and then the rest of my academic career followed that broad trajectory. So, for 30 years I've been an AI researcher through the good times and the bad times, I would say. Probably less so, actually. So I'm not a great film buff or particularly interested in sci-fi, but I have subsequently gone into that to see a bit of how AI is depicted, which is of course generally badly in most of these things, in terms of it's often the baddie in various movies. But I came at it as a computer scientist, and for me it was the most interesting bit of computer science which I was quite interested in at that point. So I'm particularly interested in AI systems in where there's more than one actor, so more than one AI system interacting with another one. So that's the area of multi-agent systems. So you have multiple agents that interact, and they might compete, they might cooperate, they might coordinate with one another to get things done. And so for most of my career I've been interested in systems where all of the actors were computer software, but latterly, in the last 5 to 10 years, I've been interested in systems where some of those actors are humans as well. So I'm interested in systems where there are mixed teams that form, coordinate, do stuff, and some of them are people and some of them are intelligent agents.
And when you said intelligent agents, I'm curious whether they can be physical instantiations like robots, or whether they could also be just software, or both.
For me, most of my career they've been just software, or they have been software. Latterly, in some of the work that we've done, they've been hardware, so they've been unmanned aerial vehicles or drones, or they've been robots, or they've been IoT devices. So for me, they've been all of those things.
And is the kind of key AI intellectual challenge and research questions similar, whether they're IoT or drones or software?
Yes, at a certain level, I've been interested in the the science and the engineering of those things. So I've built multi-agent systems in a whole variety of applications, from disaster response to supply chains to smart grids. So I've always tried to do a mix of both theory and the practical application of it. So the theory bit I've particularly focused on is on the interaction piece. So I've been less intrinsically interested in how an individual agent can behave, and more interested in how the group can behave. So I've been interested in algorithms and methods and incentives for coordination, cooperation, negotiation, those sorts of things. Good ways are harder to find, actually. I see lots of bad examples of how AI is communicated to the public, in the sense that I see quite a lot of hype and almost science fiction-like reasoning about things. I think the communication that I've enjoyed and I think is good is the bit that demystifies AI, talks about AI being a here and now thing. So we see small bits of AI in a whole variety of areas, and I like that being grounded pragmatically, and then with some of the vision of what might be. So I think that's what good communication around AI should look like.
And as a researcher, what do you think your responsibility is in terms of communicating to the public about AI?
I think it is very much communicating along those sorts of lines. So I've done quite a lot of outreach work. I've spoken at the Royal Institution, I've spoken at schools, I've spoken at events in pubs and things like that. Actually, I think it's important to engage on a topic like this, which does capture the public imagination. So some science is quite difficult to get the public interested in. I think sort of lots of the publics now get sort of AI and smart machines, but they just don't really understand what's involved in it, and they imagine that building a general AI, much like they see in all the movies, is what's going to happen. And then they're in the realms of science fiction as to, okay, if you could build that, you could imagine AI doing this, and you could imagine AI doing this, and so on. And I just don't, I think the communication is about saying what's hard and what's difficult and why that is some distance away, if it's ever going to happen. This is so much more a part of science these days. So here at Imperial we run our own science festival, so that's at a weekend. We have 20,000 visitors a year to it, and it's a staple part of what early career researchers do at all aspects. And it's also part of standard PhD training. So for all areas we really do push communication and outreach activities, and I think that's a good thing. So I see AI as mainly something that's going to work alongside people, so to augment and help them. So maybe I'll talk about a specific example of an application I was involved with. So I worked with a disaster response charity called Rescue Global, and they're people who go to the site of a disaster, try and be the first boots on the ground. So particularly we work with them around the Nepal earthquake. And we'd been working with them for a while, developing the tech, and the sort of system that we developed was really a hybrid system that used their innate human expertise and put alongside it some useful AI augmentation. So some of the things that we were able to do is we used AI algorithms to make sense of lots of what was going on in social media, what was being said, what images were being processed, and sort of, at that mass volume, which is what happens these days after a disaster. And so the AI was able to sort of draw up a picture, an assessment of what the ground looked like. So where were the most damaged areas, where were the areas of population that were most worried about, and then the humans were able to interrogate that and add what they knew. And so if they went to a particular place, they'd say, actually this isn't quite as bad as lots of people have been reporting, and therefore you can sort of ripple that sort of information back. And then when they're planning the logistics of what response teams with what equipment and what supplies go to which places in what order, actually computers are very good at that. And so that's something they used to do by hand, and we developed some planning and optimization algorithms that did that for them. And so it gave them a first cut at this is the way you should send the teams in what order. And then they changed it, or they modified it, so it sort of was a first draft, if you like, and actually they would say, well, we know, because we have some extra information that the machine doesn't, that actually this should be done before this, or this should go with this. And so the plan evolved through that interaction with them. So you've got a smart computer algorithm and a smart human working together to do that best response.
Interesting. Your example doesn't take disaster recovery and replace it with kind of a giant AI solution. Rather, it takes bits of the logistic challenge of dealing with data or dealing with constraints and suggests AI as a way of helping humans resolve those constraints.
Yes, and that's very much how I think that's how AI is going to work in the majority of cases. So I think sort of AI will do some things that we currently do, and it did some in that example of Rescue Global. That's something that someone in the team used to have to do, and the computer actually does it better, some of those things, when it's modified with human input. But actually it lets the people on the ground focus on the things that humans are good at, which is talking to people, assessing the situation, figuring out what's going on, negotiating for access to this area or to that area. So I think that this augmentation, so working alongside of humans and AI in partnership with one another, is going to be the dominant mode in which AI will come into our workplace and into our lives more broadly. I think there will be activities where it will be whole jobs that are replaced by AI, and I think sort of that's always what happens with new technology. And then of course there will be new jobs that AI will create that don't exist now. But out of those three, I think the main impact, certainly in the medium term, is that augmentation and helping us with tasks. I think it's important that when AI is introduced, that actually it's introduced in a way that is appropriate. I don't like some of the speculation that sort of humans will just do what the machine says. So I think that's a dignity question for me. When I talk about AI, I talk about partnership, and actually, partnership is a word I thought quite hard about to include, and actually, I mean it in its full sense of really working together. And sometimes the humans will take the lead, and sometimes the machines will take the lead with particular tasks, but they're working together. I think sort of there are absolutely issues with people becoming subservient to machines, and I think that would be that's a very inappropriate use of computing in general, irrespective of whether it's AI or not.
So partnership suggests more of a peer relationship than subservience.
Yes. Yeah.
How might AI tools, even in partnership with people, affect power relationships between people and other people?
I think sort of AI will give us actually the ability to democratize some services that if you're wealthy enough at the moment, you're able to get and pay for. So some of the bespoke financial services, some of the bespoke sort of health activities that are, if you're of a certain income, you can afford to pay someone to do that for you, whereas many people cannot. Actually, I think that sort of AI will even that playing field, and will give lots more people sort of access to personalized and tailored services that fit them and their circumstances.
That's interesting. It's the idea that I guess the bespoke economy is open to the wealthy right now. You have to have capital to get customized sort of high-touch services. And I think you're suggesting that AI can play that role at a lower cost point for more of us. Yeah,
so I think AI and technology, as we have more sensors around in us, so I think it's not just AI on its own, but I think about sort of sensed environments with Internet of Things devices. And I think absolutely AI will help make some of those things better and easier. The kind of system that I envisage in this sort of democratization is an intelligent agent that's acting for us and on our behalf. So it's been called various things throughout time, sort of the personal digital assistant or digital butler, those sorts of things, where actually the AI system knows has an understanding of what our preferences are and what things we like and what we don't like about particular things, and can bring those together by, it learns over time in a way that a good assistant or someone who you work closely with, you understand that relationship over time, and then it's able to do things for you. So I look forward to being able to delegate more tasks to a computer and an agent that's acting on my behalf, and I think that will save us all an awful lot of time in terms of having to organize things and get particular things done. I think computers and AI and agents will be really good for that.
So I'm going to ask an odd question, because technology's been really good at making us more productive, but causing us sometimes to spend more time on things.
Yeah.
But this is an example where the hope is that the AI actually saves us time. I'm wondering what the discrimination there is. Why that?
I think it would be interesting to figure out what we do with the things that the automated AI is helping us with. So sort of if you look at sort of various jobs that are being created, of course computers and digitalization has made things very much easier and faster. But we haven't I don't think many people have reduced their working week as a consequence of any of those things. They've just taken on more activity, and I think it would be interesting to see if that's what happens with this as well. So I see the sort of AI absolutely helping us do some tasks, but I don't necessarily think that will just give us more free time. I think we'll just do other things. And if you think about the Rescue Global example, actually what it did is it displaced their activity. So someone would spend quite a lot of time working out quite a detailed plan, and that would take several hours in some cases, and a machine does it really quickly. But they don't work 2 hours less. They go and do something else with their 2 hours, and I fear or suspect that that's what will happen with a lot of AI. So I think it will do some things, and I think in general we're quite good. Human beings are quite good or bad, depends on your perspective here, at filling their time with other stuff.
There's books about the idea of the leisure age.
Yeah.
Say actually AI will do our work for us, and we'll end up reading poetry.
Yep, I've seen those. I've seen those books. I'm just a bit skeptical whether actually that will come to pass. I think it's about how these things are brought in to applications and particular jobs. So if they're brought in in an inappropriate way, where, as I say, the human is in some sense subservient, or the human is just doing the bits that the AI can't do for itself, then I think that's a bad thing. I think we will undoubtedly see examples where AI and digitalization and automation is brought in an inappropriate way, and I think it goes back to that dignity piece of wanting to make sure that actually it works for people when we do these things. I think we need to make sure that sort of AI is as far as any technology can be, is good for those that are having to use it, and sort of it doesn't downgrade what people do in interacting with it. It upgrades and uplifts and supports, rather than sort of leaves more just a menial task that require a human to do.
Sounds like almost a design challenge.
I think it's important to get right. I think it's easy to get it wrong if you don't think hard enough about these things, and which means that I'm sure in some cases it will go wrong, and there will be examples of people who feel they just do what a computer tells them, and as I say, I think that's inappropriate and bad. I've always worked with the notion of autonomous agents, and so sort of in a multi-agent system that I've worked in, the idea is that the agents represent different individuals or different stakeholders, and so by definition it's not a single computer system with some overarching structure or organization in charge of it. So for me, sort of the autonomy is a natural bit of the problem, because it might be me interacting with you, or it might be company X interacting with company Y, and so autonomy is what you end up with as your default position for these sorts of systems. And so I think that's a natural representation of most problems. I think most problems are examples of multiple agent systems. I think a system where there's just one actor is an end point rather than sort of it's the special case rather than the general case. So I think from a more philosophical point of view, I think it works in the way that I think that that we should interact with one another. So I want to be able to give an agent or a person sort of a particular task to do, if that's what we agreed, and I'm not overly interested in the exact details of how they're going to go about achieving that, and I think that's at the discretion of individual people who might ask to do something for me, or it might be at the behest of a software agent that I've asked to do something for me.
It's interesting, your prospect for autonomy coming to your multi-agent systems research seems to be fundamentally about relationships, about the idea that you need autonomy so that you can have a real relationship between different agents working together.
That it's a realistic model of the world that it is representing. So as I say, if I have an agent that's representing me and is going out to represent me, then it acts autonomously with respect to the other agents that it's interacting with. It's, as I say, it is innate in the structure of the modelling and representation of the problem. I think the things you need to watch out for are the means by which tasks are achieved are something that you're broadly happy with. I mean, you want to make sure that in general, if you ask someone to do something for you, you have a sort of a broad envelope of expectations as to what they might do to make that so. And I think sort of what we need to be careful of when we build agents is they don't just take extreme actions in order to achieve something that you'd look at and think, well, it wasn't worth all of that pain and effort and destruction to get to that point, even though I did ask you, I asked you, you achieved the goal, but the way you achieved it is just so implausible and beyond the realms that it wasn't the right thing to do. So I think having a degree of confidence on the types of activity that go within it and the types of things that will be done as a consequence of giving an agent a goal without actually having a long screwdriver in terms of individual actions.
So there's an interesting, important tension there between giving the machine autonomy but constraining the domain in which it acts autonomously.
Yeah, I think it's important that sort of we are able to give some broad parameters in how machines should go about achieving their particular tasks in the way that we do for humans.
Stuart Russell gave me an example where he said, if I tell them an autonomous machine to buy me coffee, and I think he's used this with world leaders too, it might cross the street and kill all the people to get to the coffee machine faster.
Yep.
And so,
which would be unfortunate. And actually, if there are no ways to achieve the coffee, to get the coffee without doing a whole load of bad things, then it should just report back and say, actually, I can't do that. And I think that sort of that understanding of broad parameters of how agents will achieve their goals and the limitations of how they should act are important that we get right. And I think sort of being able to build that into our computer systems is a real challenge at the moment. So I think sort of, before we let autonomous vehicles drive around our roads, I think it's important we have confidence that they will do certain things and they won't do certain other things. I think if we're talking about sort of AI recommending some movies for you, then that's a fine thing to do, because the range of possible bad things that it can do is not very high in that regard. So I think it's proportional, and I think it depends on what we're after. So I think autonomous vehicles are interesting in that sense. So my take is that they will massively make our roads safer. So if you look at the number of people who are killed on our roads all over the world, it's an extraordinarily large number, and I think autonomous vehicles have tremendous potential to reduce that. I don't think they will ever reduce it to zero. I think there will be deaths on roads caused by autonomous vehicles, and that will be that's very unfortunate, but so is the massive number that currently get killed on our roads. So I think we shouldn't expect perfection on these things, because the world is a very imperfect place, and autonomous vehicles will sometimes make mistakes and will sometimes get it wrong, and sometimes it will be because it's a circumstance they hadn't encountered, and sometimes it will just be one of those things that nothing could be done about it.
What do you think of this idea of, well, if we give the autonomous car some form of legal personhood, then it's a target for liability, so we have a place to put our liability insurance?
Yeah, I'm a bit skeptical about that sort of line of work. I think if you take autonomous vehicles, I think that liability comes with the owner, comes with the manufacturer of the vehicle. So if it's an Audi that kills someone, then you have a discussion, and Audi is the one who's defending it, assuming that sort of it's all been kept up to date and it's all been patched, etc., etc. So assuming the user, the owner has not done anything inappropriate or sort of hacked the code or whatever might have happened, if it's been kept under normal operating conditions, I think the car manufacturers in that example need to be the responsible one. I don't know what it would mean to take an autonomous entity, robot, to court. I don't know what sanctions it would, how you would operate that. I think it has to be with the people who are bringing the service or the entity to the market. So I'm skeptical that this will happen anytime soon, or even ever. So I think we see lots of great examples of narrow artificial intelligence, so being good at specific tasks. I don't see any evidence yet that we're moving towards general intelligence, and I think going from the specific of being good at a narrowly defined task that's clear and has clearly observable parameters to functioning in a general artificial intelligence way is decades away.
So when you see, deep neural nets that do things that we thought were decades away, like Go.
Go is still a narrowly defined task, so it's an amazingly complicated, narrowly defined task. But it's good at one thing. Go is a game. It's got a clear reward function. When you're doing well, the rules of Go, and how things are arranged. It's a very ordered environment. It's very different to sort of driving autonomous vehicles on roads, which is a very much more unconstrained environment. So we do see amazing breakthroughs, but we see breakthroughs on narrow tasks.
So I go back to the driving one last time too, because I'm curious. We talked about this idea that you want this car to do the right thing, to save lives, to save us on statistics, but you also want to be able to constrain it to some degree, so it acts reasonably and under all conditions. But the conditions on a road are kind of social, right? You're dealing with pedestrians and children and dogs. How hard is that to make a car be reasonable in a social sense? Because that's not like a control feedback loop. That's something much more complex.
It's a major challenge. So getting any complex bit of software that's interacting with an unpredictable world to know what it will do and what it won't do is a significant challenge. Then you add learning and adaptation on top of that, then that's a whole extra layer of complexity. And so we really do need basic research to methods to be able to develop and specify and build these sorts of systems. I'm not convinced that we have all the requisite tools in our toolbox to be able to do that at the moment.
So it sounds like you believe we're at the beginning of the stages of figuring this out and kind of deploying the systems.
Yeah, absolutely. So there are sort of relatively simple tasks that can be automated that we can use AI for today. I think sort of that much more general in the wild for bigger tasks is something that's a decent way away, and we don't know how to do some of that software engineering, how to build computer systems that actually will behave as we would like them to in most circumstances.